In this video, we're going to use Newton's method to approximate the root of a polynomial function or the solution of an algebraic equation. It says use Newton's method to approximate the x-coordinate of the point where the graph of x cubed minus 9x minus 6 crosses a horizontal line y equals -4. Use x0 equal 1 as your starting value to find the approximation. So, what do they give us here? They basically give us an equation, and they want us to solve this. So they basically give us y equals x cubed minus 9x minus 6. And they tell us y is -4, so that would be -4 equals x cubed minus 9x minus 6. Add the 4 to each side, I get f of x is x cubed minus 9x minus 2. And I'm going to write down what Newton's method is. So Newton's method is x of n plus 1 is equal to x sub n minus f of x sub n over f prime x sub n. So in our case, we want to go through and we want to say, for the first iteration, because they give us x0 is 1, we want to say x0 plus 1 is equal to x sub 0 minus f of x sub 0 over f prime of x sub 0. Which really means we want 1 minus f of 1 over f prime of 1. So we need to find f prime. F prime of x would be 3x squared, when I take the derivative here, minus 9. And then I'm going to start plugging stuff into the calculator. So, put in both equations to start. X cubed minus 9x minus 2. Then we're going to do 3x squared minus 9. And then we're going to do 1 stored as x. And I'm going to grab those equations. I got -10 for the first one. So f, we're going to have 1 minus -10 for f of 1. And then when I grab the derivative, -6. So now I'm going to write 1 minus -10 divided by -6, and I get -0.666667. It's repeating, so it's -2/3. But that's what x1 is. They want us to find x2. So we're going to use Newton's method again. And we say x of 1 plus 1 is equal to x of 1 minus x, or minus f of x sub 1 over f prime of x sub 1. And I don't feel like plugging this piece in for x sub 1, so I'm going to just use my calculator to do all the work for this. So we're going to say x sub 1 is this number. Let's see. Well, I first got to pull the functions back. I'm going to save this one as x. Then I'm going to grab the original function. And I'm going to grab the derivative. And then I'm going to take the original number minus the original function divided by the derivative. And we get -0.184. So this is -0.184. So basically I went through and I evaluated what f of -0.667 was and what f prime of -0.667 was. And when I evaluated those, I got 3.6 7, and I got negative 7.6, and then I use those numbers in my calculator to do the subtraction. So this is what x2 is equal to, which tells us that this is an approximate solution for the above equation.